This is a 25-minute Lighting Designer presentation. Gamalux Lighting Systems is a family-owned linear lighting systems manufacturer situated in Southern California. Our most popular product line is the G-beam series of fixtures. This is that group of square and rectangular forms that have been so popular in the business for the last 15 years or so. Now, what makes our product so popular is not its shape or its size, but its ability to adapt to complex applications, which is really where we start to set ourselves apart as a manufacturer. For instance, in an application like this, you notice that the walls and the ceiling don't touch each other. And this is, of course, very unusual. Most walls and ceilings touch. The problem with that is that when a person is walking down the corridor and they look up inside this little 3-inch gap between the wall and the ceiling, they actually see the side of our fixture. Now, because this is a recessed application, most of the time you would want to use a recessed fixture in that application. But if you've ever seen the side of a recessed housing, they're not very attractive. They've got a lot of grooves and brackets and holes and things that are really not meant to be seen. And of course, all of those elements would be visible up inside that little 3-inch gap. So rather than using a recessed fixture in an application like this, what we do is we take a suspended fixture with smooth sides on it, and we modify that suspended fixture so that it could be recessed. But we don't modify the small portion of the fixture that will be visible up inside the little 3-inch gap. And by doing that, we allow for a very clean aesthetic in the space without the problems associated with putting a recessed fixture into an exposed condition. And of course, the end result is a very beautiful installation, the kind of thing that helps people to build their business and build their reputations. So we try to build fixtures while being conscientious of what's going on in the space. This is why it's very important for us to understand what's happening in that space so we can figure out the right way to modify the fixtures as necessary. Now, in an application such as this, where you have a very complex pattern of fixtures, you can actually see in the reflection in the glass here, this is one pattern of fixtures weaving its way through the entire space. Well, this actually causes a lot of problems for distributors and contractors because they can never really get a firm grasp of all the different parts and pieces that are necessary in order to order a pattern of fixtures like this. So what ends up happening is sometimes errors are made on the order, and of course this causes delays at the job site, or things, parts and pieces can't fit together properly because they've been ordered as a bunch of individuals and T or X or L connectors, and they weren't really designed as a comprehensive unit. So because Gamalux tries to deal in totality as comprehensive lighting systems, what we offer to the specifier is something we call a development drawing. This development drawing is basically the same drawing that we would provide after a purchase order, but we're going to offer it before bid day. And what it does is it takes all of the elements of that comprehensive pattern of fixtures and provides one part number for the whole pattern. And by doing that, we're allowing for the most simple form of ordering possible, because that one part number includes all the various components that are required for that pattern. Now, we know that by the time the order actually has to be built, there are probably going to be changes to the design of that pattern, but at least by providing this development drawing up front, we're starting with a known quantity. We're starting with the designer's original design intent. And later on, if we need to change power feed locations or mounting locations, or if we need to change some of the dimensions of the pattern, that's fine. We've already got an existing drawing that we can just go back and modify. Now, another thing this does for you, it simplifies, as I said, simplifies the ordering process, and it clarifies to the distributors and contractors who are bidding on this job, it clarifies to them that this is an engineered lighting system. It's not something that they have to try to put together, and this allows them to possibly do better work by understanding that this is already an engineered lighting system. Now, everything we build at the factory is actually fully assembled twice before we pack it and ship it. And of course, this affects our lead time. But it's necessary for us to go through these procedures so that we can ensure that all the housings line up the way that they're supposed to, making sure that all the joining mechanisms work the way that they should, of course, making sure that all the dimensions are accurate. Then we take apart that entire pattern of fixtures, paint it, then we put in the electrical and reassemble the entire thing as a comprehensive lighting system, checking every circuit, every battery pack. We're checking the consistency of the paint finish from one housing to the next. So by being very thorough in our methods before we pack and ship the fixtures, we ensure that everything looks and works the way that it should when it arrives at the job site. Now, if we wanted to embed fixtures into a wall, usually you don't want to see that visible flange that goes around the pattern of fixtures, so you specify fixtures as flangeless. Well, those flangeless fixtures do have a flange, but it's a mud flange. It gets mudded over and painted so you can't see it. Well, we have the same thing as well. We have a mud flange on our fixtures, but we actually separate that mud flange from our housing by a very small, about a 32nd of an inch expansion gap. Now, this is built in as part of our housing. It's not a separate back box that the contractor has to try to fit together. But by doing this, by building these fixtures with an expansion gap, it allows the housing to heat up from the LEDs or the fluorescent lamps. It allows that housing to heat up, and when it expands from heat expansion, it doesn't put any pressure on the surrounding plaster. Or if the walls, maybe it's an exterior wall, and the walls are heating up, they're expanding as well. They don't put any pressure on the fixture. So by having expansion gap built in as part of our housing, we eliminate the possibility of those cracks developing around the perimeter of our fixtures. And of course, this helps you to protect your reputation for years to come on those jobs. Now, in an application like this, we've got a bathroom mirror, and the architect wanted a half-inch reveal going all the way around that mirror. Well, normally we would put our mud flange on all four sides of our fixture, and of course, in an application like this, that means that the mud flange will actually be exposed between the fixture and the mirror, and obviously we have to avoid that. So, of course, if the fixtures are built that way, now it's the contractor's responsibility to remove that mud flange in the field, and then they have to cover up holes, and they've got to try to get touch-up paint to make it look pretty again. So what we do at Gamalux is we'll just build the fixture with the mud flange on the sides and the top, but not the bottom. So with proper collaboration, we can understand what's happening in the space, and then we know how to modify the fixture, and we do that at no additional cost. Now, in an application like this, where we're building around all four sides of the architectural environment, obviously we've got to have exact field dimensions for this pattern. We will quote to CAD dimensions, but we do not build to CAD dimensions because we know the walls will not be built to CAD dimensions. So we do require the contractor's signature approval of that corner-to-corner dimension. Now, the jip does not have to be up. As long as the studs are up, they'll know what the thickness of the jip is going to be, and then they can calculate what that corner-to-corner dimension will be. Now, this is not a custom fixture. This is actually a 4-inch wide, 4-inch tall suspended fixture on cables that is very common with most manufacturers. What we did here is we built this into patterns at the factory, but we're not leaving it up to the installing contractor to put together these complex miter joints because we know that's very difficult in the field. So we actually make this section here as an L-shaped fixture, like a hockey stick. We weld that miter here at the factory, and we're just giving the contractor a simple butt joint to assemble right here, or here, or here, away from the miter joint. And by doing that, we're giving them the most simple form of installation possible while allowing them to do good work. Now, this particular job was in a high humidity environment. This is actually in a parking garage in Seattle at AVA Medical Facility to point their customers in the direction of where they need to park to go visit AVA Medical Facility. And again, this is the kind of stuff that we can do, any angles, any dimensions. We're not bound to 4 foot, 8 foot, 12 foot, or just 90 degrees and 45 degrees and such. We have all this capability. And again, these are not custom applications. Of course, we can make all of our continuous runs fully illuminated. All of our fixtures can be built as either individuals or continuous runs, or even in patterns as well. Now, when we make these continuous runs, we're not bound to 1 foot or even 1 inch increments. We can actually cut our housings down to very small fractions of inches, and they will always be fully illuminated from end to end. To my knowledge, we're the only manufacturer left that's still able to make a 24-foot single-piece housing. Now, certainly our continuous runs can be built in any length, and there will be multiple housings in those continuous runs. But if you require a single-piece housing up to 24 feet long, we can do it. Now, also, depending on the size or the shape of that housing, if it's a tall rectangular housing like we have here, it has a lot of rigidity to it. So we can actually support that entire 24-foot housing with just 2 cables. This cleans up the ceiling system, which is architecturally pleasing. It also makes things easier to order because now there's 1 housing to order instead of multiple, and then easier to install. Again, 1 instead of multiple. And you also eliminate the possibility of pinched wires as housings are being joined together. So having the ability to make a 24-foot single-piece housing is one of the things that sets us apart as a manufacturer. Now, here's an application where we took a standard 12-foot long cable suspended fixture, very standard type of product, and we just modified it so that a portion of that housing, 8 feet of that 12-foot housing, could be embedded into the ceiling. And of course, we added a mounting component that we coordinated with the installing contractor before we started building fixtures. And now, because this housing is all one piece, we were able to actually cantilever out of the wall 4 feet and provide bidirectional illumination to illuminate that ceiling, but we didn't need the cable support from above because of the rigidity of the housing material that we're using. So again, using the strengths of the kind of components that we use in order to do very creative things that create value for the specifier as well as for everyone else involved. Now here's a residential application very similar, where they've got the 8-foot countertop, and the architect wanted the fixture centered directly above that 8-foot countertop. So we have 3 feet in the ceiling in this particular case with our mud flange for a very nice installation. And then 5 feet of the fixture is exposed. Now, because that would provide so much strain on the ceiling, we needed the support cable from above. But if it was just a couple feet extended from the wall, then we probably wouldn't need the cable. So it just depends on what's happening in the space. We'll determine whether or not we need that cable. Now, in this application here, this is in a ceiling. Of course, there's a wall right here, and then there's a ceiling right here. But it's a dual component ceiling. We have gyp, and we also have grid. So what we've done here is we made our fixtures into a pattern which interfaces on the outside of the pattern with the gyp ceiling, and then on the inside of the pattern interfaces with the grid ceiling. Now in this particular case, the grid ceiling was also raised up above the bottom of our fixture 2 inches. So the fixture is kind of semi-recessed, if you will. Now, we can do this with any kind of ceiling system. It doesn't have to be gyp and grid. It could be metal, it could be wood, it could be stone, it could be poured cement. We can interface with many different types of ceiling and wall materials, even furniture systems, interacting between different elements in order to let the fixtures become an architectural feature and not just a lighting system. Of course, we can make our fixtures into wayfinding devices as well, coming up the wall and across the ceiling. And as you remember, we can do any angle, not just 90s and 45s. In this application, we're making steps in the ceiling, but actually using the fixtures in order to accommodate that. You can see the fixtures are coming up to a point and then back down on the other side. Well, if you think about a step ceiling, there's a lot of complexity involved in that and a lot of question marks and unfortunately a lot of dollar signs associated with that kind of thing. But it doesn't have to be that case. See, what we did is we found out what the ceiling system is. In this case, it was the Armstrong Axiom ceiling system, which uses an extruded aluminum C-shaped channel up against the walls. And of course, the grid slides along that C-shaped channel and then into the proper positions, and then the tiles are dropped into the grid. So what we did is we got a hold of that C-shaped channel called the vector trim, and we attached it on the sides of our fixture at 2 different heights at the factory. Everything was cut to the same length, and then it was painted together so it all looks like one comprehensive element. Now, when the fixtures are installed in the space at the height and spacing that they're supposed to be, then the ceiling contractor gets there and just snaps the grid directly into the sides of the fixtures. The grid and the fixtures are independently supported, so they're not relying on each other, but still they interface with each other so that you have a very clean aesthetic and a beautiful installation in the space without all the dollars associated with custom construction. Now, in this application here, we have an 18-foot single-piece housing, all one piece. We're going from fully recessed with flanges down low to carry the cut tiles here so they don't fall. And then we have flanges up high to carry the cut tiles again so they don't fall. And you can see the reflection of one of the flanges here. Now, this ceiling trim that's right here, this trim is actually butting up against the side of our fixture, but because it cuts across our fixture at an angle, it's occurring at a different location in every single fixture, all the way down this side of the room, all the way down that side of the room on 6 floors. These are all one type on the fixture schedule, but no 2 fixtures were identical. We had to cut our flanges at all different lengths and different positions to allow for the proper interface of this ceiling trim. We cut our trims down to 256ths of an inch. At the end of that job, the contractor sent congratulations back to the lighting designer, who insisted on using Gamalux because we are into the fine details. We have the conference calls necessary with all the players to ensure that we have all the proper information so that we can build fixtures properly and allow the installation to look good. Now here's a different kind of ceiling system. This is the Hunter Douglas textile ceiling, where the panels snap onto the grid from below. So there's grid ceiling above, and the panels kind of snap up to and butt up against the bottom of the grids. And the panels are 1 1/8 inch thick. So right here, there's a grid up here, but you can't see it because the panels are snapping underneath that grid, and there's just a 1/4 inch gap between them. So what we did is we dropped our fixture 1 1/8 inch below the bottom of the grid so that it could be flush with the ceiling line created by the panels. And then we flared out the bottom of our fixture so it's wider on the bottom than it is on the top, so that as the fixture is raised up into the grid and butts up against the bottom of the grid, we maintain that nice 1/4 inch gap between the fixture and the adjacent panels, just like the panels have. And again, this is not a custom fixture. Here's the Armstrong Tech Zone ceiling. We can interface with either the 6-inch or the 4-inch Tech Zones. And also in the 4-inch Tech Zone, because our housing is so rigid, we can make continuous runs in the 4-inch Tech Zone without the need to break up the runs with the joiner yoke that holds the grids together. So our fixture actually takes the place of the joiner yoke and helps the grid to maintain straightness. This ceiling system here is the Hunter Douglas Box Series ceiling system, where they have the Box 4, nominal 4-inch, and the Box 6, nominal 6-inch. We've made our fixtures the same width as the panels, and we've given a spline at the end of our fixture to interface with cut panels in line with our fixtures. We also use the same brackets on the top of the fixture that the panels use, so the installing contractor doesn't have to learn anything new. So we're very much into allowing, providing the kind of components that are necessary to allow the installers to do their best quality work as quickly as they possibly can. Obviously, you have to avoid this kind of thing, these one-size-fits-all solutions that don't fit all. One size fits one, and the rest are compromises. So we don't offer fixtures like this. We always want to know what's the grid, what's the ceiling system, so that we can interface properly with that particular ceiling. Now, when you're running lighting calculations, obviously accuracy is important. So our table of output actually comes down to tenths of a lumen per foot. And so we provide these numbers for our standard output fixtures, our high output fixtures in all 5 color temperatures that we offer, with both the medium diffuse and the heavy diffuse lenses. So we always want our numbers to be as accurate as possible. As a matter of fact, we do something that nobody else does. We actually show you an image of what the bottom of our fixture looks like as you're looking through the lens with the LEDs fully illuminated behind. See, everybody has that glamour shot of the fixtures in their best condition, and that's wonderful. But nobody ever shows you what actually the products look like when you're sitting in your desk looking straight up at the fixture, straight through that lens. We do, because we want you to understand not just about the performance about the fixture, but also the aesthetics. And right next to that image in our specification sheet, there's the hot link for your IES file. There's your hot link for your Revit file. So you don't have to waste your time finding, going to our website and find the zip file that has all the IES files, and now you're playing catalog number bingo trying to figure out which one is the right IES file. They're all right there in the specification sheet, easy for you to download. Now, we offer fixtures of multiple widths from 1.5 inch wide to 8 inches wide. And so if you have fixtures of multiple widths in the space, they're going to have different output levels. What we can do is we can custom program our fixtures at no additional cost so that you get the same apparent brightness from all the fixtures in the space. And we do this because, of course, we want consistency throughout the space. And like I said, we do that at no additional cost when it's requested. Now, in addition to flat lenses on the top and the bottom of the fixture, we also offer 3-dimensional lenses, which drop or rise a 1/2 inch from the housing, and that's in suspended fixtures as well as recessed fixtures. And that's in our widths of 1.5 inch to 4 inches wide. In addition to 3-dimensional dropped lenses, we can also make regressed lenses. And because of the way that we build our fixtures, we can actually vary that width or that dimension at the factory, of course. It's not field adjustable. But we can set that dimension at whatever the specifier would like. Anywhere from maybe they want a 1/4 inch regress, or they want 3/4, or they want 3/16, or they want 2.5 inches. Whatever it happens to be, we can actually modify our housing to allow for the lens to be regressed up inside the housing at basically whatever dimension they would like. We also offer damp location fixtures. We don't do any wet location fixtures or anything capable for natatorium use where the chemicals in a pool room are eating through the housing. But if all you need is damp location, maybe there's a lot of moisture in the air like there is in Seattle, obviously we don't want that condensation to cause problems inside the fixture, so we will modify the fixtures at the factory for damp location capability. Wall washing is a very important part of good lighting design. Obviously, if you need a wall washer, there's probably something important happening on that wall, and we want to illuminate that wall as evenly as possible. So what we do with our wall wash fixture, we actually have a kick reflector on the bottom of our wall wash fixture, which allows for the top of the wall to be fully illuminated with no shadows. Not all of our competitor products have that, and then you end up with these shadows at the top of the wall. Also, the kick reflector acts as a glare shield, so the people in the room aren't actually looking up inside the fixture, which it can be quite unappealing. Now, of course, because we can build our fixtures to any length, you can go wall to wall with the construction of our fixtures down to 256 of an inch for a nice clean aesthetic in the space. Obviously, this is one of those competitor fixtures that does not have the kick reflector on the bottom of the fixture, and you can see very clearly you're creating a very visible shadow at the top of the object wall. So we want to avoid that kind of stuff. Our wall wash fixture can be built as individuals or in continuous runs and even in complex, fully illuminated patterns. In the world of perimeter lighting systems, we've done a few things that no other competitor has done. For instance, we've eliminated the gap between the back of the fixture and the wall. This is very important because this is the most visible portion of the fixture when you're sitting in the space looking up inside those perimeter lighting systems and you see this gap between the fixture and the wall. It's quite unappealing. So what we've done is we've eliminated that gap by creating a mud flange that gets mudded over on the face of the wall. And that mud flange has a little groove which receives the reflector assembly from our fixture. So the end result is when you're sitting in the space and you look up, you see that the reflector just dives into the apparent surface of the wall. It's quite beautiful. And this is consistent throughout the entire space. Now, we offer two types of illumination with this fixture. We offer grazing illumination, where we're shooting light straight down the wall. And of course, this grazing illumination obviously needs a very tight Candlepower curve, so we create that with a semi-specular aluminum reflector in a parabolic shape and a reflective lamp barrier that keeps light from hitting the direct top of the wall and instead bounces that light into the top of the reflector so it can be shot straight down. This fixture is nearly 65% efficient, which doesn't sound like a lot, but the next closest competitor is the Light Control Wall Slot 2000, and it's only 43% efficient. So we're talking about getting usable light out of a fully grazing illumination fixture. Also, notice the height of that lamp barrier. The cutoff angle is right here, so if you have a shiny tile or a mirror on the wall, you'll never see the reflection of the lamps on that wall material. Now, you have to be very careful about grazing imperfect walls. We recommend that if you're going to use our wall grazer, that you use it either on a textured wall or brick or stone or some type of scalloped material, but never on a flat wall unless you know that wall is perfectly flat, like a level 5 finish. If it's not perfectly flat, you're going to see every dimple and pimple on that wall, so we want to avoid that. And in those cases, what you want to do is the ambient illumination optic that uses the wall as a reflective surface. It bounces light back out into the space. Rather than using a semi-specular aluminum reflector, it uses a white reflector, which is diffuse, allowing light to hit it and scatter, allowing now more light to hit the top of the wall, which is why the top of the wall here is brighter here than it is here, even though this is closer to the camera. So, of course, depending on how reflective that wall is, will determine how much light bounces back. We've also reintroduced the round fixture into the world of lighting. It was gone for about 15 years or so, but we've given this rotation capability now so that the fixtures can be aimed to wherever they need to be in the space. And so round fixtures is just a wonderful geometric shape and very important as part of good design. Our G-beam portal fixture is quite a dynamic product. It uses our standard G-beam housing above, but rather than having a flat lens on the bottom, we replaced that with the Backlit Acrylic. Now, this Backlit Acrylic is quite beautiful. It's not like our competitor where they've got visible fasteners on the fascia of the fixture and actually fasteners visible through the acrylic itself. We have a very nice, clean aesthetic on the bottom of our fixture, and of course, since we were not first to the market, we believe that we had to be a bit better aesthetically. These fixtures can be built as individuals or in continuous runs. In a continuous run situation, there will be a small gap between the acrylic blocks. They can be built into gyp ceilings, grid, metal, wood, stretched fabric, you name it. So we have all those capabilities. We have 12 different models of the acrylic blocks ranging from 1.5 inches wide to 1/2 inch wide, from 1 inch exposed to 3 inches exposed, and from 3 sides frosted to 5 sides frosted, so a total of 12 models there. We offer LED, in all of our LED fixtures, we offer RGB control as well as RGB plus W, where the white circuit is a separate circuit so that you get full output out of that white. We have 13 standard finishes in all of our fixtures, and we also offer wood grain finishes in our fixtures as well for a very nice and warm type of aesthetic in the fixtures. The moral of the Gamalux story is architectural integration, and we hope that you see that we execute that well. Thank you very much for your time.